Hi everyone, welcome back to another Math 9 video. Today we're looking at 8.4, which is misleading graphs. So we're going to run through some examples of some graphs that you've probably seen before. And it may not be in math, it might be in science, it might be in a newspaper online, it might be in social studies. But they're different types of graphs, and we want to basically analyze them and understand what is going on with the information. So graphs are a method for people to share information with others. It's important, though, that they are, just like with the surveys we talked about last day, it's important that the graphs are accurate and that they don't have bias and they're not misleading. So let's take a look at some examples of some graphs that are misleading. So the first one here, we look at a percent who agreed with court, and we're looking at Democrats, Republicans, Independents. So this is American, clearly. And I guess what I would like for you to do is just to pause the video, have a look yourselves, and see if you can come up with some information about this. When you're ready for the answer, hit play again, and you'll see me going through it. So just a few things that I will mention, and we've talked about this before. We've talked about how at the bottom here, that would be what we consider the x-axis, and up here would be what we call the y-axis. So notice that the y-axis values start down here at the number 50. Then that's not entirely accurate, because if we're starting at a number of 50, then when you go up to the next value here, it goes up by 2, and that's another 2, that's another 2. So ideally, if you want to give a clear visual representation of what's going on, we would want the graph to start at 0. So that's one thing to notice. If it starts at 50, it's really just showing the top snapshot of the information that's going on here. If we were to draw this starting at 0, the difference between these values here wouldn't look like it's as great as it actually does here. So let's analyze and take a look at the actual values. So we notice that here, I guess this is a better way to show it, this one is at 62. And then if we look at the next one here, this one's at 54. So that's not that big of a difference. It's a difference of 8, but it looks like a much bigger difference than that because of how it's presented. And then if we took a look at the next one here, this one is also at 54. And again, it's just that the difference or the range between these two ends up looking like it's much bigger. So if we were to look at this, we would, like, just visually, it looks like the Democrats agreed with the court much more than the Republicans and the Independents, when in reality, if we were to zoom in on this, if we were to draw it starting at 0 and then zoom in at the top, you would notice that the difference wouldn't look so significant. It would look like they're all at about the same level. So those are things to watch for. Here's another one. So we have a look at bowling averages in this particular example, and notice that the graphs, it's another bar graph, but it's drawn in 3 dimensions. So it's actually a little bit challenging or difficult to see what the actual value is here. So if you take a look at, do you see that there's room for misinterpretation or for reading the information incorrectly? So if we look at the front, it kind of makes it look like, well, it's actually really hard to tell just by looking at the front. So probably the best way to do this would be to see where it matches up at the back. And if we were to read that from here, we would say that that's at about 120. But it's just not entirely, again, visually accurate in terms of what information it's giving us. If we take a look at this one here, we see that, well, if I want to use the same idea of going back there, then I would want to go to about here. So maybe I would say this is at around, I don't know, 113 or so. And then if we were to look at this last one here, again, it's just quite hard, difficult to get an accurate, clear reading because it kind of looks like it's a little bit above there. So maybe it's at like 127 or so. So again, a few things here. Then if you look at the front, there's a gap here and here and here. So if we were to only draw this in 2 dimensions, it would be much easier for us to read the top of the line from the bar graph over to the side to get a clear, accurate representation. But if we have information given to us like this, it's a little bit difficult to get accurate, precise results. And that also can be a little misleading to make it 3-dimensional, because when you first look at this, like again, if we were to look at these values, 113, 120, and 127, they're not that far off. There's not much of a difference between them, but look how big of a difference it ends up looking like. I feel like that in itself it's very misleading. So it looks to me like the difference here is probably about 7, and same with the difference here to here. But when you visually look at it, it really doesn't seem that way. It looks to me like Emily is way above the other two. So any which way that we look at it, it's just not exactly the best way to show how this is interpreted. So I think it might have been a better choice to just use 2-dimensional bar graphs instead of this 3-dimensional approach. Okay, so then let's take a look at this pie chart that's showing arena funding. So in this pie chart that's showing arena funding, it says over at the left here, 265 million. And then this little small green one says 10 million. And this says 85 million, and this says 50 million. Okay, so I believe you've seen pie charts in the past, but I will repeat this or mention this again, that the purpose of a pie chart is that the whole thing should total up 100%, so the total amount. And so if you take a look at this, like if this is 50 million, look at the 10 million. It's like, proportionately, shouldn't the 10 million be much smaller, a much smaller chunk of the pie? And same with the 85 million, like these almost look like they're about the same. So it's just logically not adding up and not making sense. So if the purpose of a pie chart is that we want the little chunks of pie to represent the percentage of the overall total. So the numbers and the values on here are skewed. So it's actually showing some inaccurate representation. It says it here, the sizes of the pieces of pie have not been drawn the right sizes, so it's not quite drawn to scale, which is really misleading because a lot of times viewers or people that are looking at this will see it and maybe they're taking a quick glance, and so maybe to them it looks like the green 10 million portion is way more than it actually truly is in terms of values. Okay, that's it for today's lesson. I think you'll find it's fairly straightforward. You are to do these questions 1 to 6 all. You can read through, I would suggest, so I did go through some examples with you, but I would also suggest that you look at and read the information that's in the workbook for section 8.4 and then do these questions.